But we're back, everybody. For those that don't know who I am, my name is Steve Teresi. I'm the Senior Director of Technical Services here at JL Audio. I am coming to you live from our main headquarters here in Miramar, Florida, right next door to where we make all the wonderful goodness that you guys hopefully love. Joining me today, I have Mr. Rob Haynes from Southern California. Please say hello, Rob.
Hey, everyone. Thanks for joining us today.
Fantastic. And Kevin Ferry is joining us from the greater Pittsburgh, Pennsylvania area. Say hello, Kevin.
What's happening, everybody? Thanks for joining us today.
Excellent. Kevin's going to be guiding us through a really cool training on how to use target curves, taking advantage of some of the new features in our Tune 4 software that was fairly recently introduced, along with some other fun toys that'll be going to the market pretty soon. I'll jump in at some point, and I know Rob will interrupt and have his say as well. But I'm going to stop for now. I'll pass it over to you, Kevin. Take it away.
All righty. Thanks, Steve. I appreciate it. It's interesting as we're putting this together and thinking about how we're able to show all of this cool stuff these days and not have to hide everything, right?
No more tricks to hide everything. Exactly.
Right?
It's all out in the open now.
So now that Tune 4 is out of the bag, we can really dig into some of these cooler, deeper features and why we put them in there and how they can help you when you're going through your tuning process and most likely even improve your end result too. So trying to make things faster and give you kind of that better end result or get to that listening portion, getting through that analytical portion and getting to that listening part faster and closer to your end result, I should say, because this isn't going to give you that end result. So you got to make sure you do your listening and all of that stuff. And this particular session that we're going to do is on target curves. And this one is specific to Tune 4. If you haven't downloaded it already, it is free on our website, and it is an extremely powerful tool.
How much was it?
What's that?
How much was it? I didn't get the price.
It was free $50. So,
and in Canadian, is it still free?
It's free 25 in Canadian, free
gotcha,
50
okay.
in the US. So, and it is an extremely, extremely powerful tool. So if you haven't already, please go on the website and download it on there. So if you haven't noticed, just not from us always talking about target curves, but you probably hear a lot of other people that talk about target curves also. And that is because they are extremely important. And what else also is important is the ability to manipulate them correctly and efficiently if needed, or if you want to, you'd be able to go in there and make some changes here and there. In this session, we're going to touch on what and why, and then we're going to get into using target curves with Tune 4, all the way from how to read the targets to creating your own and actually using the targets in Tune 4 on there also. So we are going to cover a lot, and we're going to cover a lot that is hands-on with this also. So what is a target curve? Well, it's a fixed frequency response or magnitude response curve. Now, we use the target curve usually as a guide for tuning when we're looking at our RTA or FFT or dual FFT measurement in Tune 4. If you take the cars kind of that you've listened to and thought, wow, we're pretty good and they sounded great and you really, really like them, and you took a measurement and with Tune 4 and then you compared all of those, most likely you would get a very similar measurement between all of those different vehicles, and those frequency responses or those measurement traces would be very, very quick to match one another on there. So you want to make sure that you take a look and understand what target curves that you want to go in and listen to and hear and all of that. So, and as we use these target curves as a guide or a tool, they are that tool in our toolbox to help us get to that listening part faster as we go through. So keep in mind, this isn't going to get us to that end result, but we want to get there faster and more consistently on there. And consistency really is a big reason why I personally like using target curves. By using a target curve, I can tune different systems, similar results, no matter what's going on. If it's my head stuffy, I went out the night before, whatever. Not that I really go out the night before, but just in case I did there, we can be very, very consistent on there. So whatever the variables may be, maybe I'm a new guy and I really don't understand what I'm listening for. So I can't easily pick out things that may be wrong in the system or oddities that are going on in there. Maybe I can't pick them out quickly, or maybe I can't pick them out not at all. So using that target curve is going to help me get to that point faster, which gives me another great point. Multiple people, if you are using the same target curve, should end up with similar results. So if you have multiple stores or anything like that, you're able to go in and have similar results if you're tuning to that same target curve between those different applications.
So, Kevin, I would want to jump in there before you said if you're the new guy and you just don't know what you're listening to. And I'm glad you expanded that, because what if you're the old guy and you know what you're listening to, you just can't hear it anymore? That can definitely happen. And what Kevin's referring to as a tool in the toolbox here is most of the tuning process is analytical, where you can analyze the system and determine what to change to make it fit the template or the target closer. And then after that, that's when you get into the, how do you like it? Does it sound the way you want it to? But that's later. What tuning to a target curve allows us to do is get to the listening part faster. The analytics should be rapid. They should be easy. That there's finite, there's a known quantity. You know where you're going with it. That's what the target curve is all about. And once you get there, that part is done. You move on to the next part. And the next part, or the best part, in my opinion, is button seat listening. That's where we want to get to fast.
Yeah, absolutely. That listening part is the fun part, and the end goal there too is getting to that part. And that's the part that we want to use this to give you that end goal. So when we do this target, we use that target to get to a goal. Many times we just say our end goal is to sound good, right? Well, what is that goal specifically, right? We could spend 5 days trying to make it sound good, but we don't have that end goal. When we have a specific end goal, it's really going to help us out. And that's like saying, I want to make my car faster, but without a goal of how fast I want to make it, I'm just going to keep spending time and spending time and spending time and money at that point in time too, to try to get my car to go faster. So by having that end goal or that target, it's a great end point. And when we go back to the cars, the same thing. You have that torque curve or that horsepower curve that you're targeting. You have a certain form that you want to go in there and get that, and that is your end goal. And that's the same thing with our target curves. We have these formed target curves that we want to match our frequency response, measured frequency response curve too. So we want to have that measurement, and it gives us a great goal to get to that endpoint of the analytical or the measurement portion of the tune and get us to that listening part of the tune faster. Now, when we look at Tune 4 in targets, there's actually 8 spots for different targets, plus 1 sum, and that sum is a combination of any of those 8 targets. You're able to go in and select which targets of the 8 that you want to combine to make your sum in there. And we've also added in additional target files to the software too, that you can even go in and download different versions of it, or upload different versions into the software itself. They do download automatically when you download Tune, and we'll get into those different versions here in a little bit. And you can go in there and you can create, save, and do all of that good stuff with your own targets. So if you use our target and you kind of make some changes to it, or you find yourself making some changes here and there when you're doing your listening portion of it, then you can go in there and change that target curve to coincide with the changes that you made while you're listening on there. So it makes it nice and easy on there. And the really nice things is these targets are easy to use. They overlay over the measurement when you're using a VXI or MVI amplifier, or even in simulation mode of an amplifier. You have the ability to have the EQ bands also overlaid on that same exact screen. So you're getting all of your data in one area, which makes it really simple, rather than having to use multiple different sources, one for measurement, one for the software, and all of that good stuff. So this is extremely helpful on there. Now with Tune 4 and Max, you do have the ability to see all 3 dimensions of audio, and we've built in all 3 dimensions into our target curves on there too, which is nice. So that's, and we'll get into kind of some of those details here in a little bit. So target curves and reading target curves. We're actually going to hop over to the software and show you a couple of these in real time. And so here we go. So we're going to hop over to Tune Software and just showing you kind of how to switch from targets and outputs. If we look over here on the right-hand side of the screen, we have our buttons between targets and outputs. Right now, orange is on outputs. If we select targets, now we are in our target mode. When we are in target mode, you'll notice that these all have a yellow banner at the top of them. That is to let us know that any changes that we make in here are actually done to the targets that are being displayed there and not the outputs of the amplifier or anything like that. So kind of gives us that nice visual reference to know where we are at on there. So if the targets aren't already displayed like we do have here, the buttons over here on the right will go ahead and remove and bring our targets up. So we can go ahead and display those targets on there. Or remove them. We can remove the sum. We can have just the sum on there if we want to. I can remove all of these and have just our target sum on there, depending on what we're doing at point in time and being able to show that on there. Now, these check marks on the left-hand side here actually go in and add up to whatever our sum is. So right now I have T1 or target 1, target 2, and T4 equal my target sum. So I can go in there and bring these up, and you can see that those 3 bands actually pull up and equal out my summed response on there. So one thing to notice when we're looking at these graphs and looking at all this is your scaling is a big thing. So we take a look down at the bottom, and I'm going to look over at my screen here a little bit for you guys. So don't think I'm looking away. But 20 hertz up to 20 kilohertz, you do have the ability to change that scaling by going up into your zoom area and right clicking, and you have your setup scale. So you're able to go in there and change that scaling if you want to make some different changes. If you want to see a little bit more or a little bit less, you can go in there and do that. You can also zoom and do all of that and change your scale in this area also. 20 to 20 K is really where I like to see everything, and I like to see only the things that I'm working with. In Tune, you can actually go below and go above that if you would like to, or if your preference is in there.
The scaling by default is 20 to 20K, and the Y-axis is also a default on that. Kevin, if you don't mind showing on the right side, the restore the default view button, next one down. All right, so that one shows everything, which looks really goofy. So the one above it is the restore default, and the bottom one gets everything on the screen in terms of the Y-axis scaling. There's lots of controls here, but if you ever get lost, just click that top button back, and then bring you right to the view that Kevin's got right now. Very easy.
And you can use your plus and minus. So when we take a look at this target curve, I'm not going to change the target curve at all. I'm just going to change some of the scaling on here. So if I press my plus key on my keyboard, it is going to zoom up. You can see my deviation steps on the left-hand side have gotten much smaller. We're at 1 dB steps compared to, when we're getting up into here. So this is the same target curve and same shape.
Stop right there. Stop. Ah! Keep it up like that. There's another pro tip that a lot of people don't know. If you take your cursor and go up to the Y-axis where like the dB scale is on the left, kind of where the EQ is, if you, like in the middle of that area, if you double click, it restores it to the default scaling on that axis. The same thing would be true on the X-axis as well with the frequencies on the bottom. If we had expanded that or contracted that, double clicking there would also restore it to the default X-axis scaling.
Look at that. I'm learning something new as well.
Like I said, a lot of people don't know that.
You weren't joking around when you said a lot of people don't know that. So, all righty. So now that we kind of got our basics of seeing the target curve and reading the target curve, let's get into a couple of the different types and kind of what goes in a little bit into our target curves here. So we're going to start off with this example here. This is our kind of normal basic target curve that we have gone in. We've done a lot of listening to this target curve to come up with it. And it happens to be the one that we use here at Jail Audio quite a bit. And it is pretty simple in a way. It is. But it's not in some other ways. These curves don't need to be highly detailed. When we take a look at some of the details that are on this, we can fight and pick over half dB deviations in there, but realistically in a car, you're probably not going to hear many of those smaller adjustments on there. So this is a great one. It's a great template to get in there and a good guide as we get through doing that tuning. Now, we get asked pretty often can you import a target curve into Tune 4 from another text file or whatever. And at this point in time, no, you can't. But there's a really good reason with this. So there's a lot more happening with these target curves than you're just seeing here. We've got this summed response with this target curve as we're looking here, but there's actually multiple targets that are creating this summed response. So when we take a look at this summed response is actually derived from two other curves. One curve is for the subchannel and the other one is for the mains. And this is a great target for doing like a pair of coaxial speakers or components with a passive crossover for example on there. Also marine like applications where you have a lot of mains and then a sub or even a home application where you're doing mains, and maybe your mains have a passive network already built into them and you're just trying to get the sub and the those main speakers lined up with one another. This could be very, very helpful for you there. I thought Steve wanted to say something.
No, just keeping the mic open in case I have something I want to jump in with.
Yeah. The yellow target is combined sum of the purple and red targets. It may be hard to see, so we're going to actually offset this so you can see that that yellow line is the combination between that red and purple trace. So when we line up our mains to our mid bass or to our subwoofer on there, that is that combined trace on there. So it's not just a yellow line that is typed in there with some X and Y coordinates on there. There's a lot more detail going into there. And what's cool is if you manipulate one of those, it will adjust the other one, which is very, very nice. So you can make adjustments to your summed response and it will manipulate your driver specific target to coincide with that, which makes it very, very nice when you're
Don't worry, we're going to demonstrate everything he just said. It's a lot to take in
with that. Yes, it is. So, and one of the other big things is that we do also take a look at the phase response of the targets on there also. This yellow trace is the sum of the phase from the purple and red traces that we've seen already. Again, this is the sum. Now let's remove this yellow sum trace, and you can see the driver specific phase traces there and how they go along with one another. It might be a little bit hard to see, but that's a good thing because they're lining up so perfectly with one another in line in the phase domain there that they are working very, very well together. And that's another thing that a lot of target curves that are out there, not only do they not offer multiples to equal a sum, but they're not offering that third dimension or being able to look at that phase application in that target also.
What Kevin's referring to about them blending in, you'll notice that there's a purple and a red phase trace there. The red one's from the mains and the purple one's from the sub, and the red just goes right into the purple, and the purple continues as if it's a single speaker at that point playing, which is ideal. That means they're completely lined up in time. Bear in mind, everyone, that this is an electrical predictive model. And this is why we use it as a target, because it's free from any of the weird aberrations that may come up in an actual acoustic measurement. Trying to line up a phase trace to an actual target phase is going to be very challenging, but there are ways to do it, and you can use this as a guide. But I just wanted to point out in its perfect sense that the two are blending one right into the next. And the same would be true if you expanded that out too.
Yeah, and if we just pick the mains so we can look at the phase trace of the mains, again, you'll see just very little bit at that bottom end portion there. There's a little bit of purple there. It is there, but you would see that if they were not overlaying with one another perfectly on there. Now, that's two speakers or two frequency responses that we're really working with. We can take that a step farther, right? And we can go up to, or actually this would be 2 or 3 steps farther, when we can go to a 4-way system. And again, the yellow trace is the sum of all of those other traces. And like we showed on the 2-way, the phase is part of that target too. When we take a look at the phase trace, that 4-way system, and we remove that yellow layout on there, or the yellow overlay on there, the sum target on there, you can see the red trace for your tweeters, the white trace for your mid ranges and mid basses, and then the purple trace there too. So all of those drivers are lining up very well. So well, when we bring that sum trace in, you can't see any of those other driver specific traces on there, because they all do line up very, very well with one another. Now, that's a lot. So what we have done to get you started is we've added in a bunch of predetermined or preloaded targets into the Tune software. So when you actually go in and create a new project with the setup tool in Tune 4, a file or a target file is assigned to that project and is associated with the speaker configuration being used. So for example, if you go in and you pick a 8-channel VX 800/8i amplifier, and you have a 3-way front setup, it's going to pick that 4-way target, and it's going to assign your tweeters to the tweeter target. It's going to assign your mid-range to your mid-range target, mid-bass to mid-bass, and sub to your pre-outs on the amplifier on there too. So we've gone through and we've done a lot of this stuff to help simplify it for the for you guys out there using them. So, and hopefully you're able to take advantage of that. Now, if you are swapping between projects, or maybe you have a project that's a little bit different than what the setup tool offers, when you download Tune, you can, or you do have the ability to go in there and change the different target files. They automatically are packaged with the software itself. So we'll go in and take a look at these. And each of these targets has been modeled for all 3 pillars, and each sum is broken up into the corresponding pass bands that equal out that sum. So we're going to hop into Tune and go ahead and show these and show how to load them in there. So while we're in our targets area there, down at the bottom is load. So we'll go in and select load, and you can see these automatically downloaded with Tune 4. So I'm going to start off by just showing the 2-way target and open that. Settings are going to be overwritten, so you can see here's your 2-way target. So again, if you have a coax or component using a passive network, this is an excellent target to go in and use. Now I'm going to go in and load, let's go in and load our 3-way. So we have our 3-way in here. So we have our tweeter, we have our mid-range, and we have our subwoofer. So if you're using a 2-way component system, tweeter and mid-range / mid-bass there, and you're doing that active, this is that trace that you would want to go ahead and do. And last but not least, we can go in there and load our 4-way target and open this guy up. And you'll notice one thing that that populates here is the subtrace actually does not populate. And what's nice is we can just easily come over here and pick T4 and populate our subtrace on there. So it makes it nice and easy.
The sub was already included into the summed response. It just was not visible on the screen. The ability to show or hide individual traces can really help out in the tuning process. Having the target sum visible at all times and then just seeing a band-specific piece of information as you're tuning the system can be very, very helpful. And again, all of it can be toggled on or off any way you'd like, and it's non-destructive. What I mean by that is, but if you hide them like Kevin's doing now, they're not gone. He could just recall them whenever he wants to. And even if you decide to override these targets, they have been saved as files, and you could recall them anytime you'd like. And you have the ability to save and all kinds of good stuff. We'll show you more about that in a moment.
Yeah, and see,
as long as you're not unchecking them, you're having no impact on that summed response.
Right.
Yeah. If you uncheck them from the summed response, then they will not equal the sum response. And I'll let Steve show that when he's creating and doing some of these other targets here. I just wanted to show the ability to hide and bring these up. And then I also want to just mention that we do add a couple other targets on here if you want to go in and utilize one of those, or manipulate them or whatever. However, we're pretty strongly for the ones that we have added in there, so much so that we've done those with our driver specific targets. We've tried these out, we've worked with them, they've gotten very good results and very close to the ending of our analytical and getting into our tuning function there. So now I am actually going to hand it over to Steve, and he's going to show us how to go through and go through and make a few and manipulate a few.
Give me control.
You've got it.
All right. So by default, when you launch Tune 4 software, this is the window configuration that you'll get. You'll have your meters and gains on top and your RTA on the bottom. So I just wanted to start with something pretty close to what you might experience when you launch the software. I've already configured my mic. We could talk more about that later if we want to. But what I'm going to do is I'm going to focus on the bottom graph, which is my Rta graph. And I'm going to go up here and I'm going to make it a larger screen so you could see more of it. And you can see I have live data. That's our little tan or brownish color trace that's kind of jumping up and down. What I'm going to do is I'm going to turn that off so it's not so distracting. So it's now hidden. And now you can see I just have my 4-way target on there. What Kevin wanted me to do was start over so you can see how to build a target curve from scratch. So what I'm going to do is I can right click on any one of these and I have the option to either just reset the target I clicked on or reset all targets. I'm going to go ahead and reset all of them. And it gives me a chance to make sure I didn't want to, do something different. So saying, okay, it's going to basically delete everything that I have currently. So I'm going to say, okay, I'm fine with that. And you'll notice now that I still have the same things selected, but there's nothing there. There's something missing. All the data is off the screen on the bottom. And if you look at this bottom area here, I think I can do, is it this? No, it's this. No, I can't figure it out. But down in this bottom area, you'll see what we call data detector arrows. And you'll see that right now there's 5 of them. There's a red, gray, a green, a purple, and a yellow. The purple one is filled in. The filled in means that's what the active trace is. And if you look at my cursor, it's also purple. So now if I hit the Z key, I'm going to rotate between them. And you'll see that my cursor and the data detector arrow is changing color as I go through that. What those arrows are telling me is all the stuff you want to see is off the screen to the bottom. So I'm going to hit my arrow key on my keyboard until I say, hey, look at that. I see something. And right now it's the yellow, right? And I see the gray here and green. All of these are down here. Why do you think that there would be a difference, in this case, of 12 dB between the purple, the red, the gray, and the yellow? Like, why is there a 12 dB difference? Anyone have any guesses? I'll wait a moment. There's a hint over here. Kevin already covered it. It has to do with something over in this right-hand corner. I know there's a delay, so I'm just going to give it a moment. I would do that theme song, but we already got in trouble for that.
I still can't believe that.
I see Dave said something about sub versus everything else. Twice as loud. You guys are getting really close on it. All of these T1, 2, 3, and 4, the check mark means they're adding up to the sum. So if I start deleting these, you'll see that the yellow trace starts coming down. When they add up, the sum becomes louder. They add. It's all additive. So that's what's going on there. All right. So what we're going to do now is we're going to start off by modifying our T1. We're going to call these our tweeters. So it's already been labeled. It doesn't reset that when you do that. So for a tweeter, what we're going to do is we're going to go to our crossovers. And we can undock this if we want. So we can actually see all of the filters if we want to. I don't think we need to right now on that. I'll come back to that in a moment. I just want to show you the dock and undock mode. So what we're going to do is we're going to turn on a high-pass filter. Let's call it a 24 dB proactive Linkwitz-Riley. And by default, it starts at 20 hertz. If I click in that area, a common starting point for a high-pass on a tweeter might be 5,000. The old way in tune would be to hit 5000. But that's annoying. So now I can do 5K and hit enter, and it automatically does that. You'll notice that the sum looks kind of goofy. There's something weird going on with that. It's adding all of these other things plus the high pass. Now, if I turn those off, you'll see that the Well, now the sum and the high pass are now the same because that's all that's being added. If I add this one, you'll see that there's a weirdness going on there. Don't fret. We're going to fix all this stuff. I'll show you. So now we have a tweeter set. Now we're going to go to the next one, which is going to be our mid-range, right? In the mid-range, we're going to have a low pass as well as a high pass. So I like to turn both of those on so you can kind of see the low pass on the top end and the high pass on the low end. I'll start with the low end. So it's a mid-range driver. Maybe it's good to maybe 400 hertz, right? And then on the low pass, we'll use the same point for 5K. So those are kind of combining. It still looks a little goofy. Again, don't worry. We're going to get to that. We're building something. Next up is the mid-bass driver. So again, we're going to have a low pass and we're going to have a high pass. We'll put the high pass, a common point might be 80 hertz. We'll come over here and we'll do, what was it, 400 that we used before? We'll do 400 again. Boy, that looks crazy. Let's add the sub. Let's just have some fun with the sub. Sub is only going to be a low pass, right? 24 dB per octave, and we'll do that at 80 hertz. And look at that. Everything looks pretty smooth at that point. There's a bit of a variation. A lot of that has to do with the mid-bass channel being lower in level because of the high and low pass filters being pretty close to each other. Now, the truth is, I'm going to hide the sum, the individual pass bands, and that is not a very good target curve. A flat line like that is not what we would normally want. What we would recommend doing is once you've assigned your high and low pass filters to each one of your band specific targets, then you select your sum target. And as Kevin mentioned before, any changes I make to this equalizer will affect all of the bands that are adding up to it. So as I move this one around, you'll see that up here, it's affecting the red one more than anything else. But now as I go down here, it's the red and the gray. And if I keep moving down, you can see it is affecting all of those adding bands, as I like to think of them. And the same is true all the way down. So if you want to do your shaping on your EQ, we'd recommend doing it on the sum trace. Do your high and low pass filters on each of the individual targets, and instead do your shaping on the sum. What I'm going to do is I'm going to pull out the EQ panel, and I find this is a really nice way of being consistent with our information. Now, the curve that Kevin was showing earlier, he kind of alluded to it being a really simple curve, and the truth is it's really, really simple. So what we do on our target curve, we have a shelving filter that we use, and what a shelving filter does before I make these changes, you'll see that it's just kind of tapering up or down as opposed to a normal parametric EQ band, which has like a curvy shape to it. Curvy is a technical term. Sorry about that, guys. But you can see that the shelving filter doesn't behave the same way. It's more of a taper. So that's really all we're going to do. I'm going to reset all of this. I'm going to come in here and I'll put in our filter for this. 7, and we like a little bit of bass there, so we're going to boost that up. So you can see the orange curve is the EQ curve, and the yellow curve is the actual target curve. So this is just an overlay to make it easier for you to see what's going on. The other one we do is here. This is at 500, and Q is a 0.25, and we do a 3 dB taper. Whoops, minus 3 dB. What that does is it just gently rolls off the top end. It tends to be very pleasing in a car. So with that, just those two filters, we have that target curve that Kevin's been showing. I'm going to go ahead and dock that. You don't have to stay with that. You can do whatever you'd like. You could also change other bands as they interact with all of that. It's a very, very powerful target generator. So earlier, Kevin was talking about the phase response. So if we go into the phase response, look at here. You'll notice that the yellow curve doesn't line up with all the other ones. This is because the phase response of each one of those pass bands is affected by the filters that we applied. And there's a tool that we can do that doesn't change the magnitude response, but does change the phase response. Should I wait for an answer, guys? What tool affects the phase response without affecting the RTA magnitude or frequency response?
Well, while we wait for, and I'm sure someone's going to get it, while we wait for that, I commented on this in the chat earlier, but playing around in target mode is so freaking cool for me because it really is an educational tool. You can actually see how filters interact with one another. I know Nick talks about learning how different drivers can interact amongst one another. So if you've never been able to figure out, well, what exactly does an all-pass filter do? You can see it in the electrical domain right here. And Dave at McKinnon got it where he said all pass filter. We got a couple others saying that as well. Quite a few.
Sean spelled all wrong. All right, so what we're going to do is we're going to apply all pass filtering. But before we do, I want to show you something. All of this is the time domain. I saw someone mention something about time correction. I think that was Frank, and Conrad made a comment about time. So just before I do the all pass filtering, which is what I want to do, I'm going to go ahead and add additional delay. In this case, I'm on the tweeter channel. You see over here, I have my tweeter channel selected. It says tweeter here, which means I'm looking at this red curve, right? If I go in here, if I add delay, you can see the change that's happening in the phase domain. That's what delay does to phase. So what we're going to do here is instead we're going to put it on an all-pass filter. And what we'll do is we'll simply start lowering the frequency until those line up. And you can hold the shift key and get resolution as you make those changes. And the idea is to get it to line up to the next pass band. So the next one I'm looking at now is this green one. This green one's way out of whack. So the green one is the mid-bass channel. I'll turn on my all-pass filter. And in this case, I have to go higher, right? If I go higher, oh, look at that. It's not going to line up. This is a little tricky at times. And normally you don't have to do it again. Like Rob said, we already have our curves in there. So in this case, I'm going to take the gray trace and make it line up to the red one first. You can see how it's already starting to line up nicely. I'll go back to the green one. Come in here and shift it like that. So now we'll go to the purple one. And we'll start messing. Whoops, not there. There we go. And kind of taper that down. And we can start dialing all this in nicely. It can be a little tricky at times. But this gives a lot of flexibility on what we can do. Now, here's some interesting things. This guy here is way too low. So we're going to start adjusting that. And you see how it's affecting the entire phase response. So now we're getting really, really close to where we want to be. Let's go ahead and change this guy a bit. And then go back to the tweeter. You can see how those are lining up. The purple is slightly out of whack. We'll go ahead and goose him up a little bit. And now when we toggle on our sum, you see how close it is to the overlay on those other traces. So now we've got everything lined up in time, frequency, and level. Everything's exactly where we want it. The three pillars have all been addressed with our target curve. And here, if you really want to blow your mind, if you want to look at impulse responses, those also will line up. The sum traces of that's some pretty crazy stuff right there, though. So just wanted to tease you on that a little bit. So we go back here, and we're back to our normal thing. So if we click our default view, you'll notice everything's off the bottom of the screen because our level is different. And there was a question in the chat, so I want to kind of touch on it here. Our data detection arrows are all pointing off the screen to the bottom. Our default view, our normal position for things is right here and around the 75 dB. The anticipation is in most vehicles. We have a microphone in the vehicle. Your level is going to be somewhere in the 75 dB, no matter what. I mean, almost by accident, it's going to happen. So what we can do is we can go into each one of these levels and put an offset. The target curves that we provide have a 74 dB offset. So when we do that, we just go down the list here and we start putting in 74 for each one of these channels, 74, and you'll see they're all starting to populate on the same screen right where we want them. So now when we close out of this, if I make changes here and I scale it or I move it some way and I go back to my default, everything shows up the way Kevin showed us earlier. That's what we recommend. Our normal default target curves are going to line up with 74 dB, as you see here, all of them at 74 dB. And the default scaling will be positioned perfectly. That's why we've done it that way.
So Kevin, real quick, Steve, if you can humor me, just to show people why we want to get the targets in phase, are you able with the summed response on, maybe turn off the individual targets and only show the summed response? And turn off the all-pass filter on the subwoofer or mid-bass channel, and you'll actually see the shape of the summed response change in that crossover region.
Right in that area there. And if I do the same thing here, you'll see another change. It's subtle, but it does make a difference in these cases. And ideally, if you're doing it, might as well do it right? And,
Absolutely.
What Rob had us illustrate right there is one of the biggest reasons why we don't have it that you could import a target curve, because you would not have the phase data and you'd have to go back in and modify everything anyway. It's also not band specific data. So again, it's sort of unfortunate, but I think it's pretty easy to create any shape you want. Oops, should have adjusted that one. That one's on band 3, sum target. I can shape this any way I'd like. So if I want to taper this down more, I can actually mess around with this guy. I could take, to band number 10, which is the shelf, and I could taper it any way I'd like. And here's a little bonus that I'll share with you. Kevin kind of alluded to the load button. Like using the load button, come on, there it goes. You'll notice there's a folder called Other Targets. And in there are some targets that we found on the internet that we went ahead and built for you. So some of them are pretty popular. This half Whitledge curve is actually pretty popular. So a lot of people like that. It's basically telling me everything you just did, I'm going to destroy, and I'm okay with that. So I do that. Now you see that target is in place. And if you look in the phase data, go in there, you can see the phase data here has also been lined up. If I toggle this off, you can see we've gone through the process of lining up the phase data for the other targets as well. We knew that out of the box, not everybody would understand how to do band-specific targets, adding to a sum and aligning phase. So we went ahead and did a lot of that for you just to be nice. At the same time, yeah, go ahead.
What's the button right next to the load button there?
The save button?
Yeah.
I don't know what to do with that. Let me go into the RTA again. So if I determine that this particular curve is not exactly what I want, and I want to maybe taper this down a little bit more, or if I want a little bit of a cut in this area, maybe make it a little bit wider so it's a little bit softer in that area. If I like that curve better, if that's suited to my taste, I can come in here and hit save. My computer's not happy with me. I need a new computer. Steve's cool new target.
Is the boss man listening about those computers?
Yeah, I'm sure he's giving it lots of attention. And I hit save. So now when I go to load, I have the option. I can load that again. I can pick any one of the other target curves. If I go back to the JL Audio 4-way, that comes back in. And I can come back in and load my Steve's new target curve, and it'll pull back that data as well. So like we said before, you can mix and match and do whatever you'd like. All the curve shaping, we recommend doing it on the sum target because it'll cascade to all the other ones. Here's another cool little pro tip. Let me go back to the JL Audio curve for a second. And pull that in. So I'm going to, on your keyboard, if you hit the E key, it toggles the EQ on and off. E for EQ toggle, right? I'm going to turn that off for a second. You'll notice I'm going to go ahead and hide all of this stuff for right now, including the sum. You'll see that T5, 6, 7, and 8, those are hidden, but I can unhide them. And these are actual different full range targets that we have in the system. So you can kind of see them all overlaid there. And here's the cool thing. So let me pull all these back on. This is going somewhere. So let's just say the yellow curve is not the one I want to use. Maybe this pink curve is the one I want to use instead. So let's figure out what the pink curve is. Target number 6. So I'm going to hide the other ones, and I've hidden so there's the yellow one. What I can do is I can launch my EQ, do something like this, right? Oops, sorry. So I'm going to put this over here. I'm going to select the global 2A, I think it is 6. We'll do that 4, 5, 6. That's this guy here. And I'm going to copy to EQ sum. And when I do that, everything scales to that as a new target. So now I just made that target 6 is now my sum target. And you'll notice all my other bands matched up to it. And if I want to, I could come back in here and do this one instead, which was this curve here, the brown one. So the sub channel will be a little bit different if I make this change. So what I'm going to do is I'm going to go ahead and do copy to EQS. And now my sum is different. So it's just that easy. If you see other targets that you wanted to create, you could hide those in these other unused targets. And you could go ahead and change those out on the fly, which is why you want to do all of your high pass and low pass filters separately from your target sum. So you can copy that EQ setting into the target and be done with it. It's such a very fast way of modifying that curve.
All righty.
What
Anything else?
Oh, yes. There's one more thing. But wait, there's more. So this high pass and low pass that I'm looking at right in this area here, it's at 5K. If you're looking at measured data, so let's go ahead and put on some measured data, and you see that the tweeter can actually extend below what the tweeter's target response is. I'm going to turn that off because this is actually just my voice. What you can do is you can undock here, the crossover panel, and you could look. There's a button up here, HP LP tracking. If I click that, it changes the shading. And now what I can do is I can pick this 5,000 hertz as the high pass on T1 and check the 5,000 hertz low pass on T2. And I can come in here. Now what you want to look at is the yellow and the gray curve and what it does to the sum trace, the yellow curve. So as I start lowering, whoops, helps to be in the right box. As I start lowering the frequency, you'll notice that they continue to sum flat. We're tracking both the high and low pass filters, but they continue to sum to the target curve, regardless of what changes I make in the frequency. Just to make this clear, if I turn off one of those, and now I make adjustments, notice what's happening to my summed response. It's no longer summing to the flat or the summing to the true target. It's altering it in a way that's detrimental. This allows us to track changes as we make those, as we make them in the interface. So like instead of 5,000 hertz and I want to go down. Now, technically you can get carried away and keep on going with this and they'll continue to sum as much as they can to the target. I don't think you want to cross your tweeters over at 1100 hertz though. So bear in mind, this is just a target and it could make you make some bad choices. So be mindful. I probably wouldn't go much below 2,500 in most cases. So if we go ahead and leave that. So now it's the same sum. It's just a different high and low pass filter on those two channels. And so is that what you wanted me to get to, Kev?
Yeah, I'm going to actually show that real time here in a second too. So it'll be pretty cool. Thank you for leading us into there. So we're going to hop back over to me. And last but not least, we're going to talk about and walk through tuning to that target curve. And in Tune 4, it is fairly easy, especially if you're using an MVI and VXI amplifier. Like I said earlier, with the overlays, all of that stuff, you can literally have everything on one screen. One of the things I do is I do have two screens. And if I'm not doing this where I have to show everything on one screen like Steve and me are doing, I'll actually use the second screen for all the dropout windows. So I'll pull out my high pass filters, I'll pull out my EQ panel and all of that stuff. And I can load that stuff up on the second screen. So that way I have a little bit more visibility of what's going on here. But again, if you only have one screen, it's way, way easy because you have one program that is running everything on there. And it does a great, great job at that. So I'm going to actually tune 3 individual drivers in a space. It's not a very good space at all. I'm actually in my office here. I'm not going to run down to a car in the next 30 seconds. I think it's like 42 degrees outside right now too. So that puts a damper in it.
It's a brisk 84 degrees here in Southern California today.
If I wasn't on screen,
we had rain, so it's cold here.
Visual message right now, Rob. But I'm going to start off and go through. You'll probably notice when I get to the subwoofer that I am in a very large area. I'm not getting a lot of gain from the room that I'm in or anything like that. So you'll probably notice it right there. But I'm going to follow the process where I'm going to mute everything, work with my levels, get my levels set, get my filters to match my high pass and low pass filters to the target, then make any minor adjustments needing, ending with my EQ to target there. And I can do that manual or I can do it auto depending on what you guys want to see. I am not using a Mac system. I'm using the single microphone. I've seen some people asking in the comments here of what do you need to have Macs for this or any of that. I'm not using Macs for this demo. I am utilizing a single microphone as I walk through it. And I'm going to actually pull up that microphone here in a second. Am I on? Is my screen on, Rob?
Yep, you're live. Yep.
All righty. So I'm going to come over to my settings. I'm going to grab my input. The input is from my sound card. I have my microphone plugged into channel 1, and I'm going to send my output from my signal generator through my sound card to my amplifier, my VXI amplifier. So we are all set up there. I can come in and grab my sound card. Now, like Steve showed earlier, I have this little pink arrow that's showing that I am taking measurements. However, my measurements are way down here. I know just from working and how things are with this that I do need to offset this around 100 or 110. So we're going to go 110 here, and that brings up my microphone so we can see my levels here. If I stop talking for a second, it would come quite down far from there, but I am talking pretty loud, and my microphone is literally right over here next to me. So
I'm actually shocked there's not more low frequency response from your voice.
Well, I'd say, you know, it's maybe in a few years it'll get lower. I don't know. So we have our microphone up and going. If I needed to make some adjustments, the nice thing is I am using an external sound card. I could go in there and make some adjustments of the level on the sound card if I needed to, or you can make it on the computer, or you can go in there and change your offset, just depending on what's going on there. You just want to make sure you're not clipping that input. If your measurement freezes, that means you're clipping your input of the sound card, and everything's freezing there on you. So,
and you can also verify that on the meters and gain.
And you can also verify that on meters and gains there too. So I'm going to actually go through. I'm going to start by just capturing traces. I am a capture trace kind of person where I try to capture everything. So the first thing I'm going to do is just run pink noise through all of our periodic pink noise through the signal generator to all of my speakers on there and capture each one individually. I've put kind of a safe spot for a high pass filter on my tweeter and all of that. So I'm at 2000 hertz because I kind of want to see where the natural roll off on the tweeter is and how the tweeter is working in that area, and also with the mid bass driver and our subwoofer there. So I kind of have some safe filters put on. I'm just going to run through real quick and grab my traces on there. So I'm going to mute my microphone here.
So Rob, that means you and I have to do the talking now.
Sounds like a plan.
All right. So what he's doing is he's started his periodic pink noise on a signal generator. He's unmuted his tweeter, and you can see that response curve has come up, and it's above his red target curve. And you can see in this case that tweeter extends below where the actual target curve is. So he's just captured that trace for reference. You can do that by clicking the capture button in the lower right-hand corner of the graph, or hit the space bar. So now he's capturing the mid trace as well, so he has that as a reference. So now you can see what the responses were before he put all the filters on. And now he's doing the same thing on the sub, I think. Or is he up the mid bass, right?
I think that's the
sub. That's the sub, okay.
It's only a three-way system.
Yeah, he's going to yell at me. I have 3 of his subwoofers sitting on my counter here.
I've been waiting for that. My little 6.5 needs 3 friends. All right, so we kind of got to look at what's going on here. We can see my tweeter does play pretty well below that filter point on there, and I can go in there and make that adjustment. One thing I do have to do is if we take a look at the mid-range, down in this area, my mid-range is not really doing well with those lower frequencies, just in the application that we have it in. So I do want to bump that target up just to give it a little bit more breathing room on there, and just be a little bit safer with that mid-range playing those lower frequencies in there. I don't want to push the drivers to do something that they don't want to just do naturally. So when we take a look at this, we're trying to take a look at what the speaker and how that speaker is reacting in my space naturally. And we can see the tweeter's doing very, very well. If I EQ that one to target and I bring the high pass filter up, it's going to be plenty safe on there. But my mid bass driver down there, I would be just a hair concerned with it. I don't want to run into any failures when I'm trying to really get on it and rail on it at times there. So I'm going to actually come into targets, and I am going to pull up my high pass filters. I'm going to switch my tracking on there, and my 80 hertz here, I'm going to grab that one and that one. So you'll notice as I move this in this area, my sum is going to stay the same like Steve showed earlier, but I am going to move that filter frequency up just a little bit higher there, and I could see that on my summed response. And now I am looking at my measured trace. I am above my measured trace, so now I can bring my high pass filter up and meet it, and I'll have plenty of outputs on there without having to worry about the driver trying to do something and work overly hard there. So I'm going to close that out. I'm going to actually remove these traces now on here. So I'm going to just exit these out so I don't need them at this point in time. And I can come in if I wanted to and remove these so I can see just my tweeter. And we are on our measure. I'm going to pull up my EQ panel. And I am going to mute myself one more time because I don't want you guys all have to listen to pink noise railing as I go through and do this. So first thing I'm going to do is kind of mess with the level just a little bit. I'm pretty close on everything. And then I'm going to set my filter frequencies. And then I'm going to go ahead and do my EQing on each driver here. So I'm going to go ahead and mute. And if you guys want to take the vocals away for me so that way they can understand what's going on. Thank you.
All right, so where is he at? What's he up to? So he's muted now, right?
Yes, he is.
All right. So let's see where's his cursor? I don't see his cursor. We usually see his cursor. Where is he? There he is. Okay, so he's gonna close on the EQ panel, right? He's gonna switch over to the outputs and he's gonna unmute the tweeter. Yep, we see you. Brings it on up. He's gonna take that and he should undock his panel. Right there we go. He's got his high pass filter now. He's going to try to line it up. Looks like he coughed or something when he was doing that. So that's pretty darn close to the red curve at that point. And you'll see that his frequency is not exactly the same as what the target frequency was, but that doesn't matter. What we care about is making the acoustic response line up with the target response. And once he's got that done, he's going to launch his, so there's his filter frequency there. I'm looking at the Facebook feed, so I should be looking at his feed. So
yeah, you're about 15 seconds behind.
Okay. So he's running the auto EQ to target and it's done. And you'll see that is pretty spectacular how close that got just by clicking a button. Now, here's the cool thing before he gets too far down the rabbit hole here. If you don't like anything that you see there, since you're seeing it dynamically and in real time, you could change anything you'd like. And you'll see those changes happen in real time as well. So you see that his measured trace is moving along with his EQ band. And I think the beauty of the system that we've put together is if you don't like what the auto EQ has done, that's fine. You can turn it off and redo it yourself if you want. Or if you want to see if you could do better, you could do it again if you'd like. And you can actually turn off individual bands if you only want to say, you know, I want to see if I could do this with 3 EQ bands. You could hide 7 of them by toggling them off and see if the auto EQ can do it with just, 3 bands or something. This way you have a couple of bands to use later if you wanted to, season to taste, as we like to say.
So looking closely at the numbers on the EQ panel, you could probably, with a lot of work and probably experience, knowing what adjustments to make, can get just as close to that. But when you look at some of them, like the Q values, the specific center frequencies, gain levels, the calculations to run complex, mathematics like that to perfectly do that fast. If anything, start with that, get in the ballpark and make some small salt and pepper changes if needed. But that's a lot of hard work that's done in a couple of seconds.
Exactly. And again, the goal of these micro automations, like what Kevin's demonstrating, is not to just like you click a button and it's done. It's you click a button and you get really close and then you can massage it if you'd like, and you get to witness what it's done and make a determination as a human, is this what I wanted or not? As opposed to just you hit the button and something happens behind the scenes, and when it's done, it says, hey, we're done. And then you're left with whatever the result is. We allow you to have full visibility, ability to redo it and change the parameters any way you'd like.
And the nice thing is that you can take those parameters and transpose them onto a different DSP if you're using something other than VXI or MVI amplifiers, which is nice too. You have the data there. You can see that data and transpose that over into the other device that you're working with.
As a word of caution, though, not everybody uses the same exact mathematics when calculating how they do their filters. So your results may vary ever so slightly. But the goal here is if you run the AutoSet EQ to target and you get it to, the real-time data won't change. You'll have to transpose that, but you will see the changes in the data as you make those changes in your DSP software, as the measurement system is actually capturing that data in real time. So you can actually do a lot of that manual. The goal here is to put you in the ballpark so that you can make those adjustments faster.
So we're getting pretty slim on time. We've kind of run into overtime. Do you want me to finish doing this, or do you want to hop into Q&A, or what do you? I can run through this quick, or whatever.
Just do the mid-base channel real quick, and then we'll jump into the Q&A.
All right.
So what he's going to do now is he's going to mute his mic again. Probably he's already done that. All right, he's going to switch to the mid-base channel, and he's going to clear off or hide some of those traces. He's going to focus in on his mid-base only. All right, so he's going to hide the other things just to clean up his display and make it a little bit easier to look at. So now he's got that visible. He's going to move his EQ panel probably. Yep. All right, he's going to go ahead and apply a high-pass filter on the low end. Get that to closely line up. It's looking pretty good. The goal when you guys are setting these filters is to have the measured data get really close to the target, but not necessarily be below it. You want it to be a bit above it. We've often said you should always try to cut down, and that's one of the things that we're trying to do there. Make sure your output is lined up to your target. Mash that AutoSet EQ. Wait a couple of seconds, and bang, there we go. And again, that's pretty good. So, that's a good course of practice there. He's going to capture the name of that trace as well, so he has it for future reference. And then you just keep on doing that as you go down the range and you go from left to right. You just keep on doing that as you do that, and you wind up with a very, very precise measurement very consistently. I don't know. I think that's pretty cool. So I think he's done, and he's going to unmute his mic.
Yeah, so you can see how close to my targets that I am on there. It's it does very, very well, especially when you get into the mid range and you start getting into some of the higher detailed resolution and stuff like that.
Hey, Kev, can you humor me for a moment?
Yeah.
Up at the top, I see it says Rta Spectrum. If you change the banding there, I think it is, right? Yeah, so you can change basically the resolution. And depending on what frequency range you're actually tuning, you can change this and it'll scale accordingly. The AutoSet EQ will look at the setting for banding before it applies it. So what I would recommend is at higher frequencies where the deviations, when they're very close together, mean much, much less at higher frequencies because of the spacing of our ears and a number of other things. You could use a lower value for the banding. So like a 1/6 is probably fine up high. But as you start going, well, it's actually a higher value, but you know what I mean. As you start going to the lower frequencies, you want a little bit more resolution, like 1/12 or 1/24 banding on that. Captured traces and live data scales perfectly. The only thing that relies on what's visible is the AutoSet EQ function itself. So you want to make sure that you have it set the way you want for the range you're doing. I find 1/6 and 1/12 is what I would normally use, except when I get down to like mid-bass and subwoofers, I might jump that to 1/24 or maybe even 1/48 if I want to be crazy.
Yeah, I normally go 1/6, 1/12, and then 1/24 is kind of. I don't hop into the 1/48 realm.
So real quick, we just had a question come through from Dave McKinnon up in Canada. He wants to see if you can change the y-axis scaling so you can see a couple of dB resolution. So if you just pick an area and zoom in, maybe the overlap area for the tweeter and the mid-bass there, kind of zoom in on that. You have the ability to zoom directly in on that. So now you see that the X and Y axis has scaled to focus in on that particular region. And we do have the ability using the arrow keys and the plus and minus keys to move up and down, left and right, and scale the X and Y axis pretty much any way we'd like. So yes, Dave, you can do that. And then mashing on the default setting brings it back into the traditional view that we find pretty good. Good stuff. All right. So
well, that's what we have for you. And any other questions that are going on or happening? I haven't looked at the Facebook comments or anything like that.
Yes, there was one early on. Let me find it here.
It was up there. Jeremy asked a question.
Yes.
Is that the one you're looking for?
I'm scrolling up on Facebook when I should be scrolling on StreamYard. Jeremy, here we go. He had a question with his microphone, pretty much talking about the offsets that we discussed before. But the targets are coming in at 75, and so pretty much the offset that Kevin talked about earlier.
Right. So the offset that we're applying is what's known as a trace offset. It's not actually changing any of the actual readings. It's just scaling them on the graph. By default, the numbers that you're seeing are what's known as dB full scale. And there's a reason for that. We don't know what mic you're using. We don't know any of the levels like Jeremy's experiencing. We don't know any of that. We have no visibility into other hardware. So the only thing we have a reference to is full scale. We know what that is. So we're going to show a value relative to full scale. And there's so many things that can impact where that is supposed to be. We can't really account for all of them. So what we would tell you to do is put the data on the graph in an area that you feel comfortable. Now, I know that doesn't resonate well with Jeremy. I know him well enough to know he wants it to be really exact. What I would then recommend is if you grab your microphone, make a minor purchase of what's known as an SPL calibrator. And what this does is you take the microphone, you slide it in there, and you turn it on. You'll love this, guys. It plays a 1K tone at a specific frequency. So if I put my mic in there, it's 94 dB at the tip of that microphone. You adjust your trace offset until it reads 94 dB in the upper window. And once you've done that, now you're at dB SPL scale. And that would be an accurate number that you can use for comparison to other systems that you've done. And that's a really cool thing to do. And you can actually save that as a calibration on that microphone as well. So that's hopefully that answers your question, Jeremy. The reason for that is there's lots of the other thing that we found is like if you're using a sound card like one of these, it has a level adjustment on it as well. So I don't know where that's going to be positioned, and that will affect where the data shows up as well. So once you get it all calibrated, lock and load, leave it alone. Just don't touch it. I have found that if you use a USB-based microphone like this one here, it's a little bit easier because there's really only one setting, and it's usually in your sound or your MIDI settings for your computer. And once that's dialed in, whenever the computer recognizes that device, you're set. You don't have to worry about those levels again. And if you've captured that and it's the mic you always use, that calibration setting can be stored within tune. And when you pick that mic again, that it'll always be exactly where you want it. Calibrate it once and you're done.
Also, when you're using a USB microphone, it's good to always use the same port, because when you move to a different port, there is a chance that the computer won't keep the settings. I found that like on my gaming computer, I plug my when I do my iRacing, if I plug my wheel or pedals into a different port, I got to recalibrate it all over again. Where if I plug into my regular port, all my settings are there. And that same thing can happen with a USB microphone as well when it comes to the sensitivity settings on the MIDI panel or sound panel in your computer.
This
we
is
did
true.
have a question that came in from Evan asking if there was a way to add any calibration files for a USB microphone.
So the ability to actually load a calibration file, like I know my my USB microphone here that came with a calibration file, there's no way to pull that data in currently with the software. And frankly, I know this is going to sound really awkward, but there may not even be a reason to pull it in. Other than the scaling differences that we just described, the frequency response of most of the microphones that I hope you guys are choosing are pretty darn good, all the way up to about 10K before it starts really starting to taper in any meaningful way. So while it may be possible in other software packages to compensate for that, we've found the need for that to be pretty minimal, unless you're dealing with a real, what's the word? Crappy microphone. I wouldn't worry too much about it. The level would be more important than the actual response characteristics. But please know that we're always working on improvements, and hopefully in a not too distant future, we'll have a mechanism. If you wanted to load those text files or data files in, we may have a mechanism in the future for that.
The other thing is, you know, sometimes you might want to mess with some of those settings depending on the noise floor that's going on behind you there too. So we don't lock you in, because if you have a high noise floor, you might want a little bit more deviation between your measured response and where your targets are. So that way you can bring that system up to a level that's well above that noise floor. So that way you're taking good measurements on there too. So that's kind of another thing. It depends. If I have a full house, I actually do mine at 100. If I have an empty house like I have now, I bring it up a lot closer at 110, because then I don't have to turn the speakers up as loud for my house.
Yeah. So what Kevin mentioned is actually an important thing. What I would recommend before you get too deep into the tuning process is to turn everything off, turn the system off, put the microphones into your vehicle or your room or wherever you're going to be tuning, and keep everything off, make it as quiet as you possibly can, and then take a capture of that. That's your noise floor. So when you start doing your analysis, if you see something weird in the noise floor, you can call that trace back up. You can toggle it hide or show. You can bring that up, and if you see some abnormality on the noise floor, that may be affecting your measurement as well. So just bear that in mind as you go through the tuning process. Evan, again, has a really important question that he brought in. He's saying that his microphone has a calibration file for pointing forward or pointing up or off axis. Many microphones that we're likely to get are intended to measure what we would consider like a transducer measurement. So like if you're working in a lab, you put it directly in front of the speaker, and it's designed to capture that information. The type of microphones that we tend to use for acoustic measurements, like in audio tuning, like audio system tuning, these are more omnidirectional. They are not as focused on that. They're not like little lasers that are pointing to where the sound is. It's more like a sphere around the tip of each one of those. So in my little array system here, I kind of have them staggered. I've seen people move them forward or back. The actual pointed direction of them on these microphones is less important. Most of the microphones, including ones like these, may have an on and off axis measurement. They're not ideal for acoustic sound system tuning, but they can do a job pretty effectively, which is why we don't worry too much about it. And again, it may sound like I don't care about the technical accuracy of it. In fact, I do care. Remember, all of this is the analytical portion, and the analytical portion is intended to get you to the point where you can listen to it. So let's just say, for argument's sake, that your microphone has a taper from 10K and higher, and it just comes down maybe 3 dB. If you get in a car and you listen to it and you say, there's not enough high frequency, change it. That the goal is to just get to the point where you can listen to it. And if you feel that it needs more, then you raise it. You have plenty of tools to raise it. And if you need to compensate for that, you could do that with your target curve. Instead of having it taper down 3 dB, have it not taper down 3 dB. Now, using that capture microphone, you'll elevate the sounds relative to what you're capturing, and it'll be closer to what you're looking for. And again, I know that sounds like I don't care. The fact is, I do care. I just don't want you to go crazy thinking, oh my gosh, I can't calibrate this. It's never going to be right. Within a given system, it is going to be right. Even the offset on the trace within a given system, it's fine. It's perfectly fine. It's only when you want to compare to other systems, which opens up another can of worms, and we're already running late. So
Jeremy says he actually changes his target now, the offset of his targets, to reflect the the calibration of his microphone. And for me, it's just for me, and I think for us, it's 6 in one hand, half dozen the other to be able to do it. However, you're changing one offset with your microphone or your measurement compared to changing multiple offsets with the target. So it works either way, but I like to do
RTA offset's a lot easier than a multiple individual offsets.
Exactly.
So and it doesn't change anything. It's just how it's being displayed on the chart itself. So
right on. Cool.
Not really a question, but a nice comment from Jeffrey Hald about single mic tuning capabilities, saying he just plugged into a known system with a VX 800/8i and a sub amp and 3-way system and subs, and he had it sounding pretty awesome, it sounds like, in under 10 minutes. So that's
you know what I like about his comment most of everything. Thank you very much for the compliment, Jeremy. Jeffrey, that means a lot to us. But the fact that you used your ears to verify, it brings a tear to my eye. That's what we want. The computers are going to get us to the point where our ears can do that final step. Too many people say, well, the computer said it's good, I'm done. No, your eyes looking at the data, then your ears to verify what they're seeing. That's the way you get it done. Don't just blindly let the computer do its job and expect that it's going to be perfect.
So one last question before we take off. This just came in from Dalen, and it's been a common question, so we'll address it again.
Sure.
Will Tweak utilize this soon? It will in the future. I don't know, you know, what soon is, but the next major update for Tune 4 will have Tweak support for the measure tab. It is a lot of work. It's a different DSP in the Tweak than found in VXI and MVI. So in a way, it's kind of starting from scratch because we got to rewrite the code for that different DSP. So it is coming in the future. When that next major update's going to be, I'd imagine probably a few months, maybe longer. You know, we want to make sure it's perfect and it works exactly the same way that it does with the VXI and MVI amplifiers. So please be patient. We will have an update for the Tweak sometime in the future, and you'll have all of these cool capabilities like you do with VXI and MVI DSP products.
What I'll add to what Rob shared is because of the differences in the DSP between VXI and the Tweak, there is a significant amount of code that needs to be rewritten. And whenever you touch the code within software, you have to go through regression testing, which that in and of itself will take about 2 months. So it will be a little while because we want to make sure that the software we put out is stable and consistent and doesn't break anything that you've already done. However, I'll also add that in the meantime, there is an ability to run what's known as dual instances of Tune software. This means that you don't need a second computer. You can actually run Tune version 1 and launch it as a Tweak. Then you can launch Tune version 2 and launch it as measure only mode. And then what you have is the ability to look at what's going on in your measure tab and make your adjustments on the Tweak. If you want to take advantage of the auto EQ to target, you go into simulation mode on the measure only version and you pick one of the VXI products. The Tweak won't allow for this at this point. The filters are going to be slightly different. So when it does the auto EQ to target, you'll take those values and you'll put them into the Tweak version of the software and you'll see the changes show up in the measurement screen. They may not be perfect, so that's when you make your minor adjustments and go from there. So it's not fluid, it's not as tightly integrated, but that type of integration and that fluidity is coming, I promise.
Yep. Cool. Well, I think that's it for today.
Fantastic. Kevin, thank you for guiding us through. Rob, thank you for helping out with everything.
Kevin was dead on target today with what he covered.
Yeah, I think so. And if it wasn't for me rambling, we would have been on time too. But obviously, we get very excited about what we've put together in terms of the new software. When the hardware is closer to actually getting to the market, we'll start covering a lot more of Macs related topics as well. But right now, we want to make sure that you guys can get up and running using your USB mic or your external sound card and get everything done. And Jeffrey caught your humor there, Rob. So, so thank you again for watching. We're looking forward to doing more of these. And if you have questions that you want us to address, don't hesitate to ask us. We're here for you. Anything we can do to help. So until next time, I'll say good night.
Thanks, everyone.